Alright, today's date is Tuesday, October 8th, 10/8, and today we're doing lesson 3-2, calculating the slope from a graph and graphing a line given a point and slope. So, let's start off with some vocab. Slope. It's generally how steep the line is. So, think about maybe walking up a mountain or something that's steep like a ramp. This one is steeper than this one, so this one is going to have a bigger slope than this one. And if I'm going downhill, then it's nice and easy, so this is kind of a negative slope. So more formally, it is the fraction of how much up or down you move when going to the right. And this is kind of the key point. You're always assuming that you're going to the right. You're never going to the left. Always assume you're going to the right. And then if you're going up, it's going to be a positive. I'll put this here. I'll put this multiple times. If you're going up, it's going to be a positive. And if I'm going down, it's going to be a negative. As long as I'm moving to the right, that means I'm starting on the left-hand side and I'm moving towards the right-hand side of the line. So there's this other point that I'm going to be using a bit during this lesson and for this entire unit really, which is the word lattice point. So if lattice sounds familiar, it's because it's like it comes from crystals, I guess, lattice crystals. But for us it just means the intersection of grid lines. So for example, if I come down here, this is a lattice point, 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 this is a lattice point. It's where these lines intersect on my grid. And usually it just intersects every 1. Even if the graph is labeled every 2, it still should be intersecting every 1, I believe. Alright, so formula. You've probably seen the formula for slope before, and there's a bunch of different ways that you can describe it. My favorite way to describe it in terms of making sense of it is it's the up or the down. So up or down. All of that divided by right. That makes the most sense to me. I calculate how much up or down. Maybe I'm only doing down, maybe I'm only doing up, but it's always to the right. Some people call this the rise over the run. How much are you rising? Maybe you're going down, you're rising down. I don't know if that makes sense. What does a submarine do? It sinks, I guess. So the rise or the sink divided by the run. And you always run to the right or the left, and I guess that works, but it assumes you can go left, which you can, it just makes it a little bit more confusing. And then my favorite way to describe this in terms of it being efficient, this is my favorite way for making sense, my favorite way of writing it to be efficient, which I'm going to be using over and over and over again, the one thing that you really need to have memorized. Whenever I say, what's the definition of slope, you'll tell me delta y divided by delta x. So you might not have seen this symbol delta before. It's a triangle. I can write this off to the side. This triangle right here, I pronounce this delta. Please write it down if you don't know this. Delta. And in math, I mean, it might have other meanings elsewhere, but in mathematics, this means change. I can write this in a different color. The change. So if I say delta y, this is saying how much is the y changing, how much is the up or down changing. And delta x is how much is the left and right, how much is the x coordinate left and right changing versus how much up and down is changing. Alright, so know that slope is a fraction, and these are all the ways you can define it. There's probably another one too, but the one that I like the most in terms of being efficient, this is the one that you need to be able to say over and over again. In order to make sense of that, this is how you should think about it in your head. Alright, so we're going to be applying this definition of slope to the next 4 examples, and then we'll be done with the notes. So, what is the slope of the line? Oh, and by the way, I should say this too. The general way that you find slope is make triangles at lattice points. At lattice points. Just having this one tip written down will really, really help you if you're struggling with slope. So I'm going to switch to a different color, make this pop out more, otherwise it can be blue on blue. So what I want you to do right now is circle all the lattice points that this blue line right here intersects. Can you find them all? All right, so here they are. You should have circled this point, this point, this point, and there's only 3 lattice points on this line. So what I want you to do is to make a triangle, and if I was being technical about this, I would be saying make right triangles. But it doesn't really matter because I assume you're not going to be making, okay, like, oh, this is a triangle right there. Well, that's great. It doesn't really help us. If I make right triangles, kind of like steps, maybe making steps at lattice points would make even more sense than triangles. But if I make steps, you can do it on the bottom, or you could do it on the top. It doesn't really matter. Maybe I can do the top down here. It doesn't really matter where you go. You could even make one really giant step right here. As long as you're making a step at your lattice points, then you're doing it right. So I'm just going to randomly choose this lattice point at 0, 1 and this lattice point at 3, 3. And then I'm going to use the definition of slope. How much am I changing in the y direction? So I assume that I'm always going from left to the right. So going from the left to the right, I'm going positive units. I'm going positive 3. So over here I'm going to say plus 3. And then when I'm going up to plus 2. The sign here matters, if it's positive or negative. Again, I could do it this way too. If I'm going up to right 3, it doesn't really matter because I'm still going right 3 and up 2, because I know that the up and down, the y coordinate is going to go on the top of the fraction, and then the left, not the left or right, but only the right will go on the bottom. So rewrite your definition of slope. Slope is equal to delta x, sorry, oh my gosh, what am I doing? Delta y divided by delta x. Notice always the y on top. If you ask why is it on top, maybe it'll help you remember that y is on top. Y is on the top, x is on the bottom. So how much am I going up or down? Y means up or down because this is the y going up and down, and the answer is 2. Y is going up 2, it's a positive 2. And then how much am I going right? This delta x is always asking how much are you going right? So I'm going right, and this is a fraction, I'm going right positive 3. And that's my answer. Positive 2 divided by positive 3 is just 2/3. I mean, I can rewrite it again if you really want me to. But there it is, 2/3. That is the slope of that line. Let's try another one. Example number 2. So again, circle all the lattice points that we have to choose from. That's a lattice point, that's a lattice point, that's a lattice point, that's a lattice point, that's a lattice point. I have a lot of different ones to choose from. Well, what happens if I make a big stair? I can do that example, and then I can do a small stair as another example. There are two, well, I guess there's a bunch of different ways to do this problem, but I want to show you 2, and you don't have to do both of them. You only need to do one for your notes, but really try to do this one on your own, and then come back and see how to do it a few different ways. So pause the video now, try this on your own. Here we go. So what happens if I do a big triangle? What happens if I go green that way, yellow this way, just to make this pop out a little bit more. So again, I'm always assuming that I'm going from the left to the right. So if I'm going from this point, that means I'm going down 4. Down means negative, because I'm going in the negative direction. Notice all these numbers are negative. So I'm going to go negative 4, and then I'm going to go right 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go right positive 8. So again, my definition of slope. Slope, by definition, is equal to the delta y over delta x, the change in y, divided by change in x. Well, what is the change in the y? What is the up and down change? Up and down change is negative 4. So it's going to be equal to a fraction. It's going to be negative 4 on the top, and on the bottom I'm going to get positive 8. And then I'll have to reduce. That's the main trick. Whenever I have a big triangle and I just don't do the 2 closest lattice points, I'm going to have to reduce. If I divide the top and bottom by 2, by 4 even, let's do divide by 4. If I divide the top and bottom by 4, divide by 4, then I get, well, 4 divided by 4 is 1. A negative divided by a positive is a negative. 8 divided by 4 is 2. No negatives to worry about. Negative 1/2 is the answer. That's one way that I can do it. let me show you a different way. Let's go down -1. Let's go right +2. Again, you could use just a smaller stair and it'll still work. Slope. The definition of slope is delta y divided by delta x, and the change in y was -1. I went down 1. Delta y always represents up or down, and then make my fraction, and then delta x. Well, how much am I going from left and right, or to the right? I'm always going to the right. I'm never going to the left. When I'm going to the right, I'm going +2. Ooh, that's a bad plus. +2, and then that reduces, well, doesn't really reduce. I didn't need to write the plus sign there, but that's the same thing as -1/2. I get the same answer. One thing to remember about these is the bottom number, the denominator, will always be positive if you assume you're always going to the right. And that's technically not mathematically correct because you could go to the left, but again, that will make our system a little bit more confusing. Let's move to the backside on example number 3. This is the second type of problem. The first two examples, example 1 and 2, refer to one homework assignment. This refers to a second type of homework assignment that you'll be working on. So we want to graph a line that contains a point, -4, 3, and has a slope of -2/5. So first what I'm going to do is I'm going to just graph -4, 3. That has to be on the line somewhere. It gave us a lattice point. It's -4, 3. So I come over here, -4 in the x direction, because x direction, then y direction, always goes x, y. -4, and then I'm going to go up 3. The line will have to pass through this point, because that's the first point that it gives us. So always start by graphing that point. And because you have Khan Academy, you can just drag around points. For this lesson, it would help to have a ruler for this. So sorry, I forgot to mention that at the very beginning. If you want to grab a ruler and make sure that you put it back, don't keep it at your desk. That would be awesome. Now I have to analyze slope, -2/5. Well, I can use the definition of slope and say, well, this is equal to a fraction. And I know what fraction that's equal to. The fraction is delta y divided by delta x. That means I have a change here, and I'm always going to assume that delta x is positive. If 5 is positive, this negative must go to the top. You can really choose where the negative goes, but we always want to assume that this negative applies to the top. That's just a good rule of thumb. The negative applies to the top. So that means if I rewrite my fraction, this is now equal to, or what this is saying is, if I have a 5 positive that goes right 5. I'll do this in quotes because that's what it's saying out loud. And on the top, delta y of -2, again, this should be a -2. Do you think that means up 2 or down 2? What would be your guess? If you said down 2, you would be correct. All right, and we have instructions right here that tells us from the point that we started out, go down 2, and then go right 5. So here we go. I started from this point. I'm going to go down 2, -2, and then I'm going to go right 5. 1, 2, 3, 4, 5. That is going +5, and that is going to be my next point. And then I make a line that goes through that. And again, your line should continue on and on. This rule, it kind of repeats over and over again. So you can do another point and make it even more accurate. So I can go down 2 again. I can say, that's a bad line. I can say go down 2, -2 again, and go right 5 again. I can do that pattern as many times as I want. +5, and I get this point right here. Do this, and you can do this backwards too. If I go up 5 and up 2 and left 5, that would also work if you do both of these are opposites. It's kind of interesting to think about why that works, but it's kind of fun too. Yeah, so now I have an even more accurate graph because I have more of these points. I can make this line come down and down forever. Technically, this line goes out to infinity forever and ever. So we do want to label this. I know I didn't do a good job on the first few examples, but the arrows on your line lets me know that you know this line continues forever and ever. It doesn't just randomly end at one of these points. So what I want you to do now is try doing number 4 on your own, based on example number 3. Please try to pause the video and try this on your own. If you're pausing the video and actually trying it on your own, you're proving to me that you have the growth mindset. Alright, so here's how you do this problem. First, I'm going to graph 2, negative 5. Go right 2, again, this is the x-coordinate, so I go right 2, and then down 5, because y is the, or sorry, negative 5 is the y. So I have my first point. And then, ooh, this is going to be hard. 1. This isn't a fraction. Normally, we always were taught that in the very beginning that slope is a fraction. The fraction of how much up or down. So we can just make it into a fraction, right? 1 is not a fraction, but if I change this to 1 over 1, that's the same thing. 1 divided by 1 is still 1. Now it's a fraction. So maybe that's a hint you need. Maybe you can go try the problem again. Now I'm going to set this equal to the slope. The definition of slope states I'm going to have delta y on the top, delta x on the bottom, which means if I'm translating or if I'm converting this into text, delta y is equal to positive 1 literally means go up 1. Delta x equals 1 means go right 1. Now we have our instructions for what to do from this point down here at 2, negative 5. So from this point, I'm going to go up 1, right 1. So I'm going to go up 1, plus 1, and then right 1, plus 1. And I can do that again, but there's our point. I can do that as many times as I want. I can go again. I can go up 1, right 1, up 1, right 1. Each of these are going to be points. And if you find the pattern, you say, oh, this kind of goes along the diagonal. You've got it. That's a point as well. That's a point as well. And I can go backwards. That's a point. That's a point. That's a point, even though it's kind of off the graph. These are all points on the graph. In fact, that's kind of the definition of a line. A line is, oh, let's go ahead and move this after we draw it because we drew it wrong. A line is the solution to all answers, or sorry, is the solution to an equation. It's all the answers. Technically, a line is made of an infinite number of points. Cool. There's examples 1 through 4. That concludes the notes. Good luck on the 2 homework assignments on Khan Academy.